Section 1.2, part 3. Dig out your compasses. We are going to learn how to copy an angle and then bisect an angle. Okay, so first thing we're going to do is you'll need your compass and your straight edge and a pencil or something to write with, and we are going to copy this angle. Okay, the first step in copying is to just draw a first angle. Like I can copy BC, no problem. Okay, meaning I don't even really have to measure because C doesn't even have to be the same distance. So I'm going to call this B and I'm going to call this C, B prime, C prime. So we denote they're different. Okay, now if I'm measuring using my compass on this angle, I can kind of get almost any measurement I want based on where I measure. Like I can get them really close together here, I can get them really far apart out here, so forth and so on. So we need a baseline for where we're measuring from. So I need to draw an auxiliary arc, basically an arc I'm going to use to do my construction and measure. So I'm going to put my compass on my original angle and I am going to draw an arc through it. This is why you cannot copy an angle from your book, because I can't put my compass or draw an arc through an angle on my book. So you'll have to copy it down on paper the best you can, sketch a similar one on paper, and then copy it from there. So I'm going to draw an arc through this angle. I'm looking for those two intersection points. Now, without moving my compass, I want it the same width. I'm going to draw a similar arc over here. So this is that baseline for where I'm measuring. So I know if I measure the width of this angle here, this angle should be the same width at that same spot. So now that I have that first arc drawn, I can come in. I can then measure how far is it from here to here on my original angle, and then come through and measure from here to here, draw my little mark, my little arc, and that tells me how wide to make my copy. So now this intersection point, this one here, and B, I connect. So then I would put A prime out here somewhere. So now these two angles are the same measure. I have no idea what measure that is. I don't know. I haven't measured it. Okay. So there it is. I copied that angle. Now we want to bisect an angle. Again, remember bisect means to basically divide it into two congruent angles. Basically, I want to cut this angle in half. Okay, so I'm already kind of halfway there with my copy because the first step in bisecting an angle is to draw this first auxiliary arc, which we already have. We already have that arc in. Now I come at this intersection point. I don't know, I stretch my compass out, and this is where I can stretch it out as far I want. I stretch it out and I draw an arc out here. And now, without changing my compass width, I do the same from the other angle. This other vertex. And if you notice, I get this nice intersection point out here. Okay. If I connect B to that intersection point, I will have successfully cut this angle in half. That angle is now in half. And I can double check my work. Come in and measure this distance from here to here. Tiny, tiny. And then this one from here to here. Pretty darn close. Okay. Ta-da. I copied and bisected an angle. Okay, next. Pairs of angles. Supplementary angles are two angles whose angle measure adds to 180 degrees. So if I have two angles that add up to 180, okay, we know that 180 is a straight line. Remember, a straight angle is 180. So the fastest way to draw supplementary angles is to do this. There is my straight line. There are my two angles. So these are not only supplementary angles, this angle and this angle. They're also adjacent because they share this side. These are adjacent supplementary angles because they add to 180. Complementary angles are two angles whose measure adds up to 90. So the easiest way to draw complementary angles is to draw a 90-degree angle or a right angle, mark it as a right angle, and then just draw another ray in there. There's my complementary angles. Now to keep them straight, alphabetically, C comes before S, alphabetically. C and then S in the alphabet. 90 comes before 180. So 90 is complementary, 180 is supplementary. In the last section, this is the last bit we're talking about for this section, the angle addition postulate. In the last section, we talked about the segment addition postulate that said that two pieces of a segment added up make the whole segment. The angle addition postulate, two parts of an angle added up make up the whole angle. So this is saying that this whole angle, we're going to use some highlighter here, angle MNQ, this whole big angle is made up from adding angle MNP. I'm going to have double eyes, so I take that little angle, sorry for the wiggly, and add it to angle MPNQ. Okay. So the two angles added together make up the entire angle. Okay. Very straightforward idea, but we use it often. For example, in task 4, in the image, the measure of angle ABC, the whole angle, is 156. The measure of angle ABD we know is 7x plus 8, and the measure of angle DBC is 8x minus 2. But I know if I add those, the measure of angle ABC has to be equal to the measure of the two pieces, the measure of angle ABD plus the measure of angle DBC. So first I just write, using my angle addition postulate, I write an equation. Now I sub in. The measure of angle ABC we know is 156. The measure of angle ABD we know is 7x plus 8. Plus the measure of angle DBC is 8x minus 2. Now we've turned this into an algebra problem that we can use our algebra skills. I'm going to put together like terms. 7x and 8x, 15x. 8 and negative 2 would be plus 6 equals 156. Subtract the 6 from both sides. 150 equals 15x. Divide both sides by 15. X equals 10. So we now know x is 10. Very common. We would just circle our answer here and say we're done, but we're not. It says to find the measure of angle ABD. ABD. Well, that's 7x plus 8. So I take 7 times 10 plus 8, 78. So the measure of angle ABD is 78. And the measure of angle CBD. So the measure of angle CBD is 8x minus 2. So 8 times 10 minus 2. 80 minus 2 is 78. Well, I just discovered that DB, these are both 78-degree angles, and 78 plus 78 is 156. Since these are both the same angle, they're congruent. So I would say angle ABD is congruent. Remember our congruent symbol to angle CBD. So I know that ray BD is the angle bisector because the angle bisector of angle ABC. Sorry, kind of squished over there. We know this ray BD bisects angle ABC because it divides it into two congruent angles. Interesting.